Oh, hello. Didn't see you there. My name is Evan Falconeer. I'm from Group 5, Section 16.
Hi, I'm Nick. I'm part of Group 5 from Lab Section 16.
Hello, my name is Josh Saravalo, and I'm...
Hey there, my name is Trey. I'm a mechanical engineering student here at Central Florida. The goal of this project was to design and build a model of a vehicle with the lowest possible drag within the given guidelines and constraints. We also needed to perform a flow and visualization around the model. The vehicle had to include 4 rotating wheels with a minimum ground clearance of 10 millimeters. It also needed to be solid with a length of 15 centimeters and a total weight of 50 grams. A minimum load of 1,000 grams or 1 kilogram needed to be supported between the axles. Finally, the model needed a hook at the front to attach to a drag sensor located inside the wind tunnel.
Our initial plan to meet the project's requirements was to meet together and outline the specified constraints listed in the guidelines. We then discussed our strengths and divided up the tasks individually that best fit our team. We decided to take advantage of Nick's fluid dynamics software that really aided in foreseeing our model's performance. We also considered material and decided that foam would be the best since it is light, cheap, and easily shaped, all while still being reasonably durable.
This is the car model that we made for our semester project. Some of the design considerations that were made in order to keep this as light as possible and also trying to minimize the drag coefficient with it. It was made with a foam laminate, so this is comprised of multiple foam sheets that were glued with an industrial glue. It was then sculpted using a belt sander and one-to-one cutout of the CAD file for reference. So most of the contours and curvatures of this model are fairly accurate compared to that CAD model. Some of the changes that were made with this from the initial model that we had are the cutouts for the wheels in order to have the 32 millimeter wheelbase. And one of the more interesting design choices in making this is coating the entire surface of this car with glue and then sanding that smooth. It covered up some of the pores of the foam, allowing for a smoother skin surface of this, reducing the drag of the car model. There were definitely some challenges in making this and working with the foam in particular. This was all made by hand. There was no CNC or 3D printing involved, so it was definitely difficult making sure that everything to this was to specifications pretty exactingly.
So this is the original drawing that was used to make the first prototype for our measurements lab. The first thing that was designed in Autodesk Inventor was this side profile from there. The rest of it was extruded out from the 3D model. There were some changes from this initial model. We had to narrow it a little bit. The width in this model was too much. We also had to add some cutouts in the wheel wells to accommodate the specified wheelbase. But this side profile was also used in modeling the flow using a fluid dynamics software. So this was the flow visualization that was done using the side profile of our vehicle. You can see a lot of turbulent flow coming out the back at the trailing edge, especially at the tip. There's a lot of vortices forming, a lot of circular motion under here. So this was the flow that was recorded during the lab. You can see the smooth, turbulent flow over the top of it. And then at the very back, you see the same thing that you did in the flow visualization. You have the vortices appearing right at the tip of the trailing edge.
This project incorporated students to construct a modeled car in order to test the drag force. The drag force is the force resisting relative motion between the object and the surrounding fluid. The drag force is affected by an object's dimensions, weight, and size, as well as the relative velocity between the fluid and the object. One of the main concepts of this lab is learning drag force and the effects it has on the velocity of an object. In this experiment, 2 cars were examined in order to see how an object's size and weight affects the drag force. A fog machine and a black light were also used to examine the airflow over the objects. Many important concepts in this lab are used in the engineering field. An engineer constructing an airplane would test the drag force of the plane in order to ensure that the plane is equipped to fly and the most efficient. An object with a higher drag force will be less efficient. Some of the world's greatest inventions were created using the concepts we observed in this lab.